Hi, my name is Stephen Brown. I'm doing my Milestone 3 verification. My Milestone 3 was to verify system integration with the USB. So what I'm going to show you is how we send instructions across the USB channel to our DAC module, and then how we can retrieve all the measured data back via the USB so that we can use that data to reconstruct the EIT image. So if you'll come in, I would like to show you the setup of this. In order to send information across the USB channel, I had to define a packet protocol structure. So right here we can see all of the packet structures. I define a prefix and a suffix for each packet. The packets that will be sent across from the GUI are 4 bytes in size, and then the packet, there will only be 2 packets coming back from the DAC module. One is a status packet and the other one is a measured data packet. The status packet will only contain 3 bytes with a prefix and a suffix and 1 byte of status, and then the measured data will contain 98 bytes, prefix, a suffix, and 96 bytes of data, which is 3 bytes times 32, as we have 32 channels to read from, and the ADCs collect 3 bytes worth of data. I've also defined some error codes so that we know when an invalid instruction has been sent across, or when a current, ground, or node, or any of the suffixes don't match up, which would mean that we had some distortion in our packet structure. So what I did was I loaded this program that integrated everything onto our board. So what this program does is it comes in and sets up the USB, and it sets up the DAC module, it defines all of our variables, and then comes in and cases on the USB connection state. So we know that our DAC module will only send back or receive instructions or send back measured data when the device is enumerated. So right off the bat, we handshake with the host computer so that they know that they're talking to the correct device, and then we go through and once we've set the current value and we've set the specific nodes for the current to be injected into and for ground to be connected, then we measured all the ADC data and we send it across the USB again, and then we reset that status so that we can loop back and wait to receive the next ground and current node combination. So what I'll do is open up my device manager, and you'll see the ports right here. If I plug in the USB into my computer, then it will refresh and automatically connect what is called the virtual COM port. This one's connected on COM port 11, and that's the USB device. So if I open up this program real term, what we can do is here on channel 11, we'll open up this port so that we can talk to it, and then we'll start sending instructions. So right off the bat, we have to send it this instruction DE and AD hex in order to handshake with the device. And when we do it, we get back BEEF, which is what we would expect. Now we can go ahead and send across instructions. So I'll send across this packet. As of right now, I'm just going to send an arbitrary value of current. I'm just going to send 0 so that we're not setting any current, but this is the correct packet. So if I send this across, then what I can do is check the status, and this status right here tells me that the current value is set. Now if I change this to set the ground node, this will set the ground node to channel 7, and I can check the status, and a 5 is a combination of binary 4 and binary 1, which tells us the ground and the current value are set. And finally, I'll send across a current node, and once I do that, we automatically get back all the measured data, which is what we expect since this module right now currently isn't connected to anything. we would get all zeros back, which is what this packet sends, but it lets us know that this is all the data. Now, the current only has to be set once in this module, so if we go back down here and we set another current node, then we can check the status, and the status tells us binary 2 is the current node is set and the current value is set. And then I'll set a ground, and we can see that once again we got measured data back. So this completes the verification of the integration of my Milestone 3, as this will receive instructions from the GUI that are formatted in that manner, and they'll send across the USB channel to our DAC module that then interprets the instructions, executes them, and sends back measured data. Thank you.